In the previous episode, Claire and Mary found a function that described April's height above the ground as she rotated around a Ferris wheel. Claire stated that the function was 36 times the sine of n plus 40, where 36 represented the radius of the circle, n represented the angle of rotation measured in radians, and 40 represented the height of the midline above the ground. In this episode, they will reflect on how to modify a sine function and use a modified sine function to find more heights on April's journey.
So, like, if we were to apply this to anything, like to any circle that's moving up or down or something like that, it would be x for the radius times sine of n for the radian measure plus the height to the center of the circle. So I'll do h.
Okay. So maybe on the left side, I really like the way you explain that. Can you write like what, like x equals height of, or, radius length, like in words?
Oh, yeah.
X equals radius.
And then n equals radian. And then h equals height from the ground.
I like the way you write your A's.
Thank you.
I also like our sparkly pen. It's very fun.
Or like, I'm just gonna rewrite that height to center point.
Okay.
Okay.
Maybe find two more points on the Ferris wheel and figure out how high above the ground she is.
Whoa, why did it do that?
My pen's just better, I guess. There. Let's find
that one, because that'd be 5 pi over 4.
And then let's find... Oh, we already have that one, though.
Yeah, we don't need that one.
We already have that one. We already have...
Oh, you know what we could do? We could do kind of what we did, like, when we split this one in half. Like that.
A little itty-bitty piece?
Hello. Gosh.
The students decided to find two more heights at 5 pi fourths radians and 9 pi eighths radians. They now use their calculator to help them find those heights.
Like when we split it in half, so then it would be an eighth. Well, it's not an eighth, but like it's split into eighths at that point right there.
I see.
So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9 eighths. So at 9 pi over 8. So let's do that one first.
Okay.
36 times sine of 9 pi over 8 plus 26.22. Does that sound correct?
26.22?
That's what we subtract because we're below the thing.
I mean, that makes sense. Because that's...
Yeah, that's about
36?
halfway, actually, yeah.
Yeah.
So 26.2.
Is it 26? That was 22.
Yeah, it was 26.22.
Oh, yeah.
Feet.
There you
And
go.
then we'll do this one, which will be, make another one. 36 times, so we said it was sine of, hello, 5 pi over 4, right? Yeah.
Oh, yeah, it is, because it's 1 over
5 pi over 4 plus 40.
14.
And that makes sense too. 14.5. Just say
Okay.
14.5.
14.5 each. Okay.
for this one. And for this one.
In this lesson, Mary and Claire figured out how to modify the original sine function, sine of n, to create a function that gave April's height above the ground at any angle of rotation. When we change the sine function, we get what we call a sinusoidal function, which describes patterns that oscillate. X times sine of n plus h is an example. If we wanted to, we could put in specific values for x and h to get functions that would give April's height above the ground as she traveled on different Ferris wheels with different radii or whose midlines were at different heights above the ground. In the next lesson, the students will explore another application of the sinusoidal function to model temperature data.